So we're going to unfortunately encounter problems that don't have solutions today. And to start with, there are 3 basic scenarios where we might have that situation. Kind of take a look at the top. Perhaps you don't have enough information. Okay? I have to go 600 miles. How long is it going to take me to get there? What would you say to me? How fast are you going? Right? How fast can your car go? Are you walking? What rate are you traveling? So that would be no solution. I don't know. It depends. So that's no information. Or number 2, the given facts lead to an unrealistic result. In other words, you've solved the equation, but perhaps you end up with a negative time. So I say to you, how far, I'm going to go this far, and you go distance equals rate times time, and you come up with time equals -6. -6 hours. Is there such a thing? Not in this universe. Okay? -6 hours doesn't mean anything. Okay? Or the given facts are contradictory. Okay? Maybe I say, I'm traveling 600 miles to go to Grandma's house. After I've traveled 1,200 miles, there is still 300 miles to go. How long will it take me? That's nonsense. Okay? It's nonsense. So both of those scenarios can't be true if I'm truly going 600 miles, right? If I've traveled 1,200, I'm an idiot. Okay? Example 1. Example 1. So if you look at those 3 reasons why something might just not work out, you'll be okay. So, Ginny, that's funny, Ginny Zhang. There's actually a Jinhee Zhang here. Okay. Ginny Zhang drove at her normal speed, but then road repairs forced her to slow down by 10. Okay. So, originally, she was traveling a certain rate, and then her slower rates, right? And we've already learned that rate times time equals distance, right? So it's not gonna be labeled for you, this problem has no solution. You're actually gonna have to attempt to work it out. So rates given so far, Ginny started out at a certain rate, but then road repairs forced her to drop her rate by 10, right? Still, she made her trip in 3 hours. Find her normal speed. Well, so the first 2 hours of her trip were fast. The total is 3 hours. So what does that mean she did at her other dealy bobber? 1 hour, right? Okay, so 2R and then 1 times R minus 10. Still, she made the trip in 3 hours. Find her normal speed. I don't know how far she went. So, add these together. How far did she go? I don't know. If you look at those scenarios from the other day, motion in same direction, yeah. First part of the trip, she was going this speed. The second part of the trip, she was going this speed. It took her 3 hours to get there. I don't know how fast she went. Okay, I don't know how far she was going. In order to get this information, I need to have more information. So you would say to me, no solution, and maybe not enough information might be your other thing you'd say. Okay? But before you go and say, no solution, don't assume that every single problem in this assignment is no solution either. Okay? No, don't assume that. Okay. Example 2. A lawn is 8 meters longer than it is wide. I'm going to assume that they are giving me some sort of a backyard shape. It is 8 meters longer than it is wide. And it is surrounded by a flower bed. Oh, this is one of those scenarios. I know you guys love these. It is surrounded by a flower bed. How pretty. That is 5 meters wide. Okay? Find the dimensions of the lawn if the flower bed is 140 meters squared. Okay, so they have told us that the flower bed, which we're going to call the change, is 140 meters squared. Okay, they're telling us that this is 140 meters squared. All right. Find the dimensions of the lawn. So the lawn is the smaller piece, right? So the lawn, which I'm going to do in purple, is W times W plus 8, right? So we're going to do the big section minus the little section. Yes? The green? Okay, I'll stop using it. All right. Isn't it? Okay. The big section is W plus 8 plus 10 because that increases by 5 and 5. So W plus 8 plus 10 is W plus 18. That's the overall W plus 18. And this section is W plus 10. That's because the W was increased by 5 and 5. Do you guys see why I got that? W plus 10. So I'm doing this minus that. Okay? So I'm going to quickly solve this, which is going to be W squared. 10 and 18W is 28W. And 10 and 18 is 180. Okay, and I am going to solve negative W times W is negative W squared. Negative W times 8 is negative 8W. And all of that still equals this. Okay, let's collect our terms. The W squareds cancel each other out. 28 and 8 becomes 20. W plus 80. All of that equals 140. Am I right? I mean 180. That should be a 1 there. That should be a 1 there. Sorry about that. 10 by 18 is 180. Okay, let's subtract 180 so that we get our W's alone. And you got negative 40 equals 20 times width. Divide by 20, and you get W equaling negative 2. How do you have a negative 2 as a measurement? No can do, buckaroo. So this would lead to an unrealistic result. So you better not tell me, well, the width is negative 2, Mrs. Myers. I'm going to ask you where exactly I could see that. No good. No solution. Okay? Yes, you were able to solve it, but the numbers didn't make a lick of sense. Okay? This is not realistic. You cannot create a yard with an area of this with these dimensions. The numbers don't work, right? I weighed 200 pounds. I lost 100. Now I weigh 175. Nope. Those numbers don't work. These numbers didn't work either. Okay? Moving on to example 3.
That's probably how it feels. Yeah, when you think you lost 100 when you lost 5.
Example 3. Raul says he has the same number of dimes and quarters. All right, so it looks like I'm comparing monetary amounts. Dimes, quarters, they're both the same. I'm just going to call them N. I'm not sure what's going on here. And he has 3 times as many nickels as dimes. Nickels. 3 times as many nickels as dimes. Okay, so it looks like this is the count of the information I've been given. You guys have done problems like this before. Count multiplied by the value each will give you the total amount of money that you actually have. All right, let's see what they tell us. The value of his nickels plus his dimes is 50 cents more than the value of his quarters. So nickels plus dimes, 3n plus n, is 50 cents more than the value of his quarters. N plus 0.5. Looks like a reasonable equation. The value of his nickels added to the value of his dimes equals or is 50 cents more than the value of his quarters. Okay, well, let me keep going here. The dimes are 10 cents each. The quarters are 0.25 and the nickels are 0.05. So 0.10n is dimes, 0.25q is quarters. 0.05 times 3, what do you get? 0.05 times 3, you get 0.15. 0.15n. Okay, so now I've got this, this, and this. Because count times value gives you real money amounts. All right, let me try this again. The value of his nickels added to the value of his dimes. So here's the value of his nickels added to the value of his dimes is equal to 50 cents more than the value of his quarters. Okay, so I had all this stuff down, then I converted it all to the values. So now we can start. 0.25n equals, n, 0.25q plus 0.5. So I combined these, and that should be an n. I'm going to subtract 0.25 to get all my n's isolated on one side. And I end up with 0 equaling 0.5. No solution. Okay, this was just the counts. I just wanted you to see how it was working. Multiplied out and combined, this was your actual equation. The value of added to the value of is equal to this amount more than that. Okay, no solution. The numbers don't work. The numbers don't work. Okay. All right.